Here's the answer to Day 2, Problem 1. Identify the slope and y-intercept for the graph of y equals -3/5 x plus 1. Let's find the slope of that first. Now, slope is also called rate of change. When we've done this problem in the past, we have found the rate of change by putting in numbers for x and then observing how the value of y changes when the value of x changes. And every time we've done that, there's an observation that we made that when an equation is in this form, where the variable y is alone, and then after the equal symbol is the x term, after the x term is a constant number, the observation that we made is that this number here that is being multiplied to x, it's called the coefficient. The coefficient of x turns out to be the same thing as what we get when we work out the slope. And so without doing any work, just looking at the equation and looking for the coefficient of x, the slope is -3/5. Let's get the y-intercept. In the past, when we've wanted to find the y-intercept, we have taken the equation and filled in 0 for x. -3/5 times 0 makes 0, and 0 plus 1 makes 1. But at the time that we did that, we noticed that there is just a 1 in the equation to begin with. So without doing any work, we can use the constant term as the y-intercept, 1. So here's the slope of our diagonal line and its y-intercept. And we can do part B, graph the equation. Let's start with the y-intercept. The y-intercept is at 1 on the y-axis. So go right there and put a dot. There's the y-intercept. Now let's get the slope, -3/5. Remember what a slope of -3/5 means. It means that the value of y is decreasing 3/5 of a unit every time the x increases by 1 unit. And we can make use of that fact to find another dot. So let's start here. And increase x by 1 unit. Now we can decrease y by 3/5 of a unit. 3/5 is a fractional amount. If we were to consider this amount of space as having 5 small pieces in it, then 3/5 of it would be 3 of the small pieces. 1, 2, 3. It takes us down a fractional amount between this grid mark and this grid mark. Now we could repeat this process and go over 1 again and then down 3/5. We could repeat this again, over 1 and down 3/5. And again, over 1 and down 3/5. And over 1 and down 3/5. Now, it's not the easiest thing to do, especially when the grid marks are pretty small little squares. It's not so easy to do to guess fractions accurately. Now, if the fraction was like a half or something, it's pretty easy to find exactly halfway between marks. But a fraction like 3/5 is very challenging to be accurate. So there's something else that we can notice about the rate of change, -3/5. Instead of thinking of it as the y value decreases 3/5 of a unit every time x increases by 1, notice what happened when we repeated this process 5 times. We ended up back on a grid line, not somewhere in between the grid lines. And compared to the original dot, let's look at how much change has occurred from this dot to this dot. The y value has decreased 1, 2, 3 spots. And the x value has increased 1, 2, 3, 4, 5 spots. That decreased 3. That increased 5. Think of this as a rate of change. Negative 3 over 5. That's what our slope was to begin with. So this gives us a very powerful way to find additional dots on grids where even though the slope has the look of a fraction to begin with, we don't have to actually count any fractional pieces to find another dot. Instead of thinking of this as negative 3/5 over 1, let's just leave it in the rate form of negative 3 over 5 and use the negative 3 as the change in the y value, meaning go down 3, and then use the 5 as the change in the x value, meaning go right 5. And that gets us another dot on the line. And so through this original dot, the y-intercept, and this dot here, we can draw the line. Now, day 2, problem 2. The table shows a person's weight during a dieting program. Assume the relationship between the quantities is linear. Find and interpret the rate of change and initial value. Let's find the rate of change first. How quickly is the person's weight changing on their dieting program? From this row to this row, the x value increased by 2 months. And in that time, the y value decreased by 2 pounds. Writing these changes as a rate, this is negative 2 pounds in 2 months of time. This reduces to just negative 1 pound in 1 month of time. A person's losing a pound every month. So another way to write that is negative 1 pound per month. Let's get the initial value. What was the person's weight to begin with before the person started the dieting program? Well, there's not a row that has 0 for x, but we can use the first row of the table and work backwards to find out what would be the weight when x is 0. We only need to go backwards 1 month of time. So let's start with 202 pounds and go back 1 month and figure out what was the person's weight a month ago. If a person's losing a pound per month, what was the weight 1 month ago? So 202, add back that 1 pound, that's 203 pounds. And that's the initial value.